I have a class I teach called Math for Elementary School Teachers, where we talk about where the numbers that we use came from. And we start with the natural numbers, then we expand that to the integers, then the rational numbers, and the real numbers, and that's where we stop. Now, for most things, the real numbers are all you need, but there's a problem with them, right? Take a look at these equations. They're really similar to each other, but one has solutions where the other doesn't. And this is the kind of thing that just bugs mathematicians. We really like for every polynomial equation to have solutions, right? So here's how we're going to fix that. We're going to literally invent a new number, right? The problem here is that if we try to solve this just using our usual methods, right? We move the one over to the other side, and then we take the square root of both sides, we immediately get into trouble because there is no real number that when you multiply it by itself, that when you square it, you get -1 or any negative number, right? So here's what we're going to do. We're going to define a new number. We're going to let I be the unique number such that I squared is equal to -1. That is literally going to fill in the gap that we need to solve equations like this. Or equivalently, right, if you take the square root of both sides, you could also say I equals the square root of -1. Just get curious why we pick I, right? Think imaginary, right? The name was originally coined by the philosopher, who's also quite a mathematician, Rene Descartes, who honestly was being sarcastic about it. But that's why we're going to use I for our new imaginary number. Okay, so here's our big new numbers, right? A complex number is a number that can be written in the form a plus bi, where a and b are real numbers, right? A is called the real part, b is called the imaginary part. A number where a is equal to 0, we'll see an example of this in a minute, is a pure imaginary number. Okay, so I've got some examples here for us to look at, right? 3 plus 2i, a is 3, b is 2. We don't have to stick to nice integers. We can use, irrational numbers like square root of 2 and pi. We can use fractions. All of that is perfectly fine. This number here is also imaginary. This is a pure imaginary number, right? This is that case we talked about on the last slide where a is equal to 0. And this number here, this is also a complex number, right? If you take a equal to -3 and b equal to 0, this is what you get. Right? So these complex numbers, they are in no way intended to replace the real numbers that you've grown up with and been using very effectively for I don't know how many decades. We are extending the real numbers in a way that's going to let us solve equations that we couldn't solve before. Okay, so what's next? Well, the first thing we need to be able to do is simplify square roots that have a negative number under them. Right. So first we're going to talk a little bit about simplifying. Then from there we're going to go on and talk about doing arithmetic with these complex numbers. Because if these numbers are going to serve as the solutions to equations, we have to be able to check our results. We have to be able to substitute them back into the original equation and make sure they really do work. So any of the arithmetic stuff, multiplication, subtraction, exponents, the whole 9 yards, that we could do with real numbers, we also need to make sure that we can do with these new complex numbers.